This video is for 3.6 example number 1. To see example number 2, go to the other video titled example 2. Okay, so in 3.6, basically you're answering the same questions you were asked before, except the difference is you have a table, and table of values. And so when you're given this table, notice that we have a closed interval. That's going to be important later. You know the f of x, which is the y value. You know f prime, which talks about slope, and you know f double prime, which is x double prime, which is all about concavity. So the first question just jumps right into absolute max or absolute min. We're actually going to do this last, so we'll come back up and do part A. Alright, so for part B, over which intervals is f increasing, the first thing you're going to do is write your justification. I think this is the easiest. So normally we said something is increasing when its derivative, f prime, is positive. So you go up here and you say, where is f prime positive? Right here. So this is the interval that you're going to write, 2 to 3. Okay, similar for decreasing. Okay, your justification first, you're going to write because f prime is less than 0. And so I'll just box these. So we got negative here, and so these two intervals. You cannot include 1 because at 1, f prime is not less than 0, it actually equals 0. So this may be helpful for some of you that have always been wondering why we can't just skip over that 1 and go 0 to 2, because of our justification. Alright, I'm going to erase this so that it's all cleaned up for the next problems. Okay, so looking at the next one, over which intervals of the graph of f is f concave down, we need to look at our justification, which would be because f double prime is negative. And so we look at our table, look at f double prime, and we find negative here and here. And you write these two intervals. Again, you cannot include 2 in that. So we're going to write 1 to 2 and 2 to 3. You can always use parentheses here. I'm not including the endpoints. Concave up. If you think you can do this on your own, pause the video, try it. F double prime greater than 0. And that would be, I'll box this one, that would be just 0 to 1. Okay, so that's similar things to what we've already done. You're just reading a table instead. Point of inflection, same thing. Normally we would say because f double prime changes signs, same thing. Just look at the table and figure out at what x value is that happening. So f double prime changes from positive to negative at x equals 1. Here it remains negative, so again I'm not going to pick 2. So x equals 1 is the answer there. Alright, now when you're graphing, I'm going to come back up here and I'm going to erase this because I may want to mark on this in a minute. So when you're graphing, you want to first figure out, okay, I'm increasing, basically, you want to start with the point, and that's given on the table, which is 0, 1. Okay, I'm going to start there. We can go ahead and actually plot all these points. So 0, 1, 1, 0, and 2, negative 1. And we're in a closed interval from 0 to 3. So I'm actually not going to graph anything over here or anything over there. Okay, the graph is just going to be in here. I'm going to erase that because you really don't want that in your graph, but just to make a point, we're not graphing outside those bounds. Okay, so let's think. On this first one, remember the y values are positive, we were decreasing, and we were concave up. So what that's going to look like, you got to put a curve to it so that it's clear that it's concave up. Okay, you basically have 4 choices of this graph. If you think about a circle being cut in fourths, it can be like this, 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 or this. You just got to pick the right one with the right concavity. So for 1 to 2, we have the y values are negative, we're decreasing, and now concave down. The second derivative is negative. So again, decreasing, but concave down. You got to make sure there's a curve in there. It can't look like a straight line. And then for the last one, again, y values are negative, positive, first derivative increasing, negative, concave down. So this is going to look something like this. Alright, and if you notice right here, if I clean this up a little bit, we have a cusp. We got to think, does that make sense that we have a cusp there? Well, remember the first derivative was undefined there. It makes sense. You can't take the derivative of the cusp. Alright, so that was example 1. Oh, almost forgot. We need to find the absolute max and min. I told you we were going to do this last, now we got to do it. Hopefully you're not dizzy from all the scrolling. So right here, that's going to be our absolute min. And then up here we have our absolute max. And so absolute max is occurring at x equals 0, absolute min is occurring at x equals 2. So we go up here and write that down. Now I know normally we write the y value when we're talking about absolute extrema, but here we're not going to write the y value. We could, but it only asks for the x coordinate, so that's all you need to write. And on other problems, finding the y coordinate isn't even possible.